Okay, so today we're going to start Chapter 6. Chapter 6 is the same thing that we did in Chapter 5, but now we're going to change the unit of measure. Instead of measuring everything in degrees, we're going to measure everything in radians. And we are going to review how to convert radians to degrees and degrees to radians. Most geometry courses cover this. If you took geometry honors here, we do cover converting degrees to radians and radians to degrees. So, first of all, we need to define what a radian is. And a radian is its angle with its vertex at the center of a circle that intercepts an arc on the circle equal in length to the radius of the circle, which has a measure of 1 radian. And I know that's a mouthful. So I will explain what I just read to you. So in my circle here, remember that whenever you have a radius or a radii anywhere in your circle, it's always going to have the same length. It goes from the center to the edge of the circle. So what that radian definition states is when you make your angle of theta here, the radius lengths, the sides of this are the same, and then the arc measure or the length from radii to radii is also going to be a length of 1. So we're going to learn how to, or review how to convert from degrees to radians and radians to degrees. But before we do that, when you are looking for a radian measure of an angle, it's equivalent to about 57 degrees. So in the last chapter, our full circle went from 0 degrees to 360 degrees. In this chapter, our entire circle is going to go from 0 radians to 6 radians. So if you notice on my circle, 1 radian is about here, and I told you it's about 57 degrees. So I'm saying that this angle right here is about 57. And then 2 radians, if I double 57, or times it by 2, that's about 114 degrees, which over here in quadrant 2 is where 2 radians are located. Yeah. What you need to take away from this is 1 radian is located in quadrant 1, 2 radians are located, or is located in quadrant 2, which will be around 114. 3 radians are just before 180, so just before the semicircle. 4 radians are located in quadrant 3. 5 radians are located in quadrant 4. If you multiply 57 times 5, it's probably around 285. And then 6 radians, like Christian just said, if you multiply 57 times 6, you get 342. So 6 radians is just before 360. But that's what we're going to be talking about when we're measuring our angle measures in radians. So we'll be basically talking about from 0 to 6. 6 radians isn't exactly the full circle, but it's close to it. So the conversions that we're going to be using is if you're given the measure in degrees and you want to turn those into radians, you're going to take your degree measure and you're going to multiply it by pi over 180. If they already give you the measure in radians, to convert it to degrees, you flip it to the reciprocal and multiply it by 180 over pi. So we're going to practice converting from degrees to radians first, and then from radians to degrees. So let's take a look at our first example. Oh, before we do that, this is just a screenshot of what I just said. So the first one, if you want to convert from degrees to radians, we multiply the degree by pi over 180. If we want to convert a radian to degree, we're going to multiply it by 180 over pi. Now we're going to practice it. So here's the first example. It wants me to convert 45 degrees into radians. So in order to convert, I'm going to multiply 45 times my conversion factor, which is pi over 180. Now, once I do this, I'm going to be leaving my answers in terms of pi when the instructions say to give an exact answer. When they ask for an approximated answer, we're going to be using our calculators and we're going to use the pi button. The pi button is located on that up caret or that up arrow. You have to hit second and then you would hit that arrow button. That's if you have the TI 83 or 84. It's right below the clear button. So when I taught this 2 years ago in Geometry Honors, we left our answers in terms of pi. So there were no calculators. So what we're doing here basically is simplifying the fraction. So what I can do here is I could put a 1 underneath if that makes it easier for you. And then I'm going to try to figure out what can I divide 45 by and 180 by. 45 actually goes into 180 evenly 4 times. This becomes a 1. So 45 degrees is equivalent to pi over 4. And this is an exact value. So when you see the instructions that say exact, we're leaving it in terms of pi. Now, we just saw this in the unit circle song. When they sang it, 45 degrees is on your unit circle. So if you memorize pi over 4, or if you forget that 45 degrees equals pi over 4, you just do the conversion. Now, if it says to give me an approximate value of this, you're going to use your calculator, and you can do 45 times pi divided by 180, or you could even do your simplified one. You could also just do pi divided by 4. Both of these should approximately give you 0.7854, and it'll specify what I want you to round to. So either way, we would get this. Now, again, let's see if this makes sense. So if in my picture here, if I knew 1 radian is about 57 degrees, then if I were to draw a 45 degree angle, which is a little bit less, and that's my 0.78, which is like 3/4. It's a little bit less than 1. So my answer makes sense that 45 degrees is less than 1 radian. It's about 3/4 of a radian. So just make sure when you're doing these calculations that they make sense. So now we're going to convert 330 degrees to radians. Again, I'm doing the same thing. 330 times pi over 180. When I want an exact answer, I need to simplify the fraction. Now, whenever I see, like with a 0 here, I always say, okay, I'm going to cross off a 0 here and a 0 here. And now I'm just going to divide 33 and 18 by the same number, which will be 3. So I can change this to an 11 and this to a 6. And this gives me 11 pi over 6. Again, this is the exact answer. I'm leaving it in terms of pi. Now, if it asks for an approximation, then I could either take my 11 times pi and then divide it by 6, or just do the original problem. 330 times pi, divide by 180. Both of these should give you approximately 5.7596 radians. And again, if you think about it, remember 5 radians, we're down here in quadrant 4. A 330 degree angle is somewhere here in quadrant 4. And it's probably a little bit beyond because we said 5 radians was probably about 285. So a little bit beyond that, so 5.75 is a reasonable answer. Conversion. We're going to multiply 90 times pi over 180. Going to simplify because I want an exact. 90 goes into 180 twice. So 90 degrees is equivalent to pi over 2 radians. And now if I want to approximate it, pi divided by 2, or the original problem, 90 times pi, divide by 180. Both of these will give me 1.57 radians. So again, if you think about it, remember I told you 1 radians was here, 2 radians was over here. So here's your 90 degrees. So it's halfway in between 1 and 2 radians, which is 1.5. So it's making sense that the answers I'm getting seem reasonable. Now we're going to go the other way. Now we're going to go from radians to degrees, and we're just going to flip that conversion. We're going to put 180 over pi now. So now this is in radians, and they want me to convert it to degrees. So I'm going to take my radian measure. I'm going to multiply it by 180 over pi. Notice the pi's will cancel. And now I just need to simplify the 6 and the 180. I can divide them both by 6, and this becomes 30. And now I'll multiply what remains. And 5 times 30 is 150 degrees. Same thing, radians to degrees. So 3 pi over 4, multiply that by your conversion, which is 180 over pi. The pi's cancel. I can also simplify the 180 and the 4. 4 goes into 180. 45 times. I multiply what remains. 3 times 45 is 135 degrees. My next example doesn't have a pi in it, so there's no pi to cancel. Now, at the beginning, we realized that 1 radian was equivalent to 57 degrees. However, they're going to want a more precise answer, so you're going to need to involve pi. So if you want to just estimate your answer, you could just quickly multiply 57 times 5, see that you get 285, but what we're really going to have to do here is multiply 5 radians times 180 over pi. No pi to cancel, so I'm going to multiply and get 900 over pi, and then to get my degree measure, I'm going to divide 900, and I'm going to use my pi button, and again I'm going to estimate this because it's going to be a decimal, 286.48 degrees. So over here when I estimated it with the 57, again my answer of 286 is reasonable. And again, if you think about it, 5 radians is down there in quadrant 3, and so is 286. I'm in quadrant 4, sorry. So 5 radians is over here, and so is 286 degrees. Yes? If they give you angle measures and there's no little circle, no degree symbol, then you're going to assume that you're in radians. Okay? So like on this question, notice how they just gave me the degree measure with a 5. If they don't have the word radian after it, or there's no degree symbol, you're going to assume you're in radians and not a 5-degree angle. Next is a screenshot from your textbook. These are common angle measurements and radian measure equivalents. Now, these will be common ones that you should know. Once we start working with the unit circle, it'll become automatic. However, if you ever forget that 90 degrees is equivalent to pi over 2, you can always just quickly do the conversion. So for example, if I said, what is the radian equivalent for 90 degrees, and you thought you memorized it, but you forgot, multiply it by pi over 180, and then simplify, and you still get pi over 2. So common ones, these will all be on the unit circle. However, you can always quickly do the conversions. And you could go the other way also. So for example, if I asked you what was the degree equivalent for 2 pi, and you forgot, you can always multiply it by 180 over pi, and then get 360 degrees. Either way, yes?
So you can only memorize the angles and then just convert them?
Either way, yep. Whatever's going to be easiest, because right now you're comfortable with working with angles. So either way. All right, so down here, I've got my unit circle or my circle drawn on my X and Y axis. So over here, we know that this is both 0 degrees and 0 radians. And then if it's a full circle, it's 2 pi or 360. If it's a semicircle, then this would be 180 degrees or pi. And again, we can convert it. If you know that the semicircle is 180, you can always just multiply it by the conversion, and that's how it turns into pi. Okay, so 2 more formulas. So far, you need to memorize pi over 180 is used to convert degrees to radians. And then 180 over pi is used to go from radians to degrees. You also need to memorize these 2 formulas. The first one is to find the arc length, and that's a piece of the circumference. So an arc length would be how long that arc is. An area of a sector would be the area of this piece of pizza or a piece of pie. So normally we would do the area of the whole circle, and then we would have to find out what portion of that whole circle is the area of that piece of pizza. So in this case, remember the area of a circle was pi r squared. So if I wanted to find the area of the whole circle, I would have done, and using this circle with a radius of 2, I would do pi times 2 squared, or 4 pi would have been the area of the whole circle. In this case, this is a 90-degree angle. Notice it had a right angle mark. So if I wanted to find out what portion of that sector, or what the area of that sector is, I would do 90 over 360, simplify it, and then multiply it by the whole area. And then I would find out that it's just pi. However, we're just going to use these 2 formulas. Our theta measure must be in radians. So if I give you a question where theta is measured in degrees, we need to convert it by multiplying it by pi over 180. You can either choose to convert before you plug it into the formula or do it within the formula. And I'm going to show you an example of each. So the first one, notice I'm given a radius and I'm given my theta measure. My theta measure is in radians. So I'm going to calculate both the arc length and the area of my sector. So you're going to memorize that the formula for, let me do the arc length first. The formula to find the arc length is S is equal to R times theta. So S represents the arc length, and R is the radius, and theta is the angle measure. So all I'm going to do here, and these will be calculator questions, so S is equal to 18.2 times 3 pi over 8. If I'm going to key this in my calculator, so if I'm going to do this in my calculator, what I'm going to key in is 18.2 times 3 times pi divide by 8. This is approximately equal to 21.4 centimeters. This is part of a circumference. So whenever we're finding an arc length, it's always going to be whatever the units were originally given for the radius. Then to find the area of this sector, the formula I'm using for area of a sector, area equals 1/2 radius squared times theta. So area equals 1/2. My radius is 18.2. I need to square that, and then I'm going to multiply it by 3 pi over 8. So again, you can do 2 things here. You can either know ahead of time that 1/2 is 0.5, and then you can either do 18.2 times 18.2, or you can use your square button, and then times 3 times pi divide by 8. Once you do all of this, you get 195.12. Units for area are always squared. Everybody good on the first example here?
Do we have to put centimeters
Yes. So again, remember that the formula that we're using, the theta must be measured in radians. So you can do this two ways. I could convert this ahead of time by multiplying this by pi over 180, get the radian measure. However, I'm just going to put this into my formula. So my formula for arc length is radius times theta. So I'm going to go ahead and take my radius, which again is 18.2. Now, this is just coincidental that both problems had a radius length of 18.2. It's going to change. The theta will change. The radius length will change depending on each circle. So then my theta measure, remember, must be in radians. So instead of doing this ahead of time, I'm just going to put it in here. And now I'm going to key this in my calculator. So what I'll do in my calculator is 18.2 times 144 times pi divide by 180. And I don't really need the parentheses here. These x's aren't variables, they're actually multiplication. Once I hit enter, this should give me 45.7 centimeters. And then now I'll find area of the sector. Area of the sector formula is 1/2 radius squared times theta. Again, the theta is still in radians. So area equals 1/2 18.2 squared. And again, I'm going to do my 144 conversion in here. So now I'll multiply. You can either use your square button for the 18.2 or just times it by 18.2 two times. So 0.5 is my half times 18.2 times 18.2 times 144 times pi divide by 180. And your approximately will get for your area of the sector 416.25 centimeters squared. So what you need to memorize from this section is that when you're converting from degrees to radians, you're going to take your degree measure and multiply it by pi over 180. This will give you your answer in radians. If you want to go from radians to degrees, you're going to take your radian measure, you're going to times it by 180 over pi, and this will give your answer in degrees. The other thing you need to memorize from this lesson is that arc length, to calculate it, you're going to multiply radius times theta. So this will give you the arc length. And then area of a sector is area equals 1/2 radius squared theta. So this is for area of a sector. These are the 4 things that you need to memorize from this chapter, or from this lesson, sorry, from section 1. Slide, it actually lists all the homework for section 1. Your only homework tonight, this is 6.1a, it's due tomorrow. This is 6.1b, it's due Monday. My earlier class said the homework was really quick. When you see the instructions that say for an exact answer, you're leaving it in terms of pi. When it says an approximate value, you're using your calculator.